6 months ago, your infrastructure was clean. Infrastructure as code matched deployed resources. Documentation was current. The abstraction worked beautifully. Provision resources through Terraform. Everything automated, everything consistent. Today, deployed infrastructure has resources not in your IAC. Manual changes made during incidents that were never documented. Service accounts nobody remembers creating. Configurations that diverged from standards. The abstraction that promised simplicity has drifted into complexity through 1,000 small deviations nobody tracked. And now you're under load. Traffic is 3x normal. The abstractions that worked fine at low utilization are showing cracks. API rate limits you never hit before are suddenly constraints. Auto-scaling that responded instantly now lags minutes behind demand. Cold starts that were tolerable at low volume are crushing user experience at high volume. The abstraction is still technically working, but it's not working the way it used to. It drifted from its ideal state. It's stressed beyond its design assumptions, and you're discovering its limits. Let's talk about what happens to abstractions over time, under pressure, and at their ultimate boundaries. Abstraction drift is when the actual state of abstracted systems diverges from the intended or documented state, causing the abstraction to become less reliable, less predictable, and less effective over time. Configuration drift erodes abstraction consistency. Your infrastructure as code defines the desired state. Reality. Engineers make manual changes during incidents. Someone tweaks a setting through the console just to test. Someone deploys a quick fix that bypasses the standard process. Each change is small. Cumulatively, they create drift. Now your deployed infrastructure doesn't match your IAC. The abstraction promised infrastructure as code equals infrastructure reality. Drift broke that promise. Performance drift happens as systems age and load changes. When you first deployed, abstractions performed beautifully. Over time, databases accumulate data and queries slow. Caches fill and hit rates drop. Network paths change as providers optimize routing. Abstraction performance characteristics drift from initial benchmarks. The abstraction layer hasn't changed, but the implementation underneath has, causing behavior to drift. Abstraction promises drift under different conditions. Your serverless abstraction promises infinite scale. True at 100 requests per second, at 10,000 requests per second, you hit concurrency limits, rate limits, and cold start impacts you never encountered before. The abstraction's promises were implicitly conditional on usage patterns. Different patterns reveal that promises drift. They're not absolute, they're contextual. Documentation drift creates knowledge gaps. Abstractions are documented when implemented. Documentation describes how things work, what configurations mean, what dependencies exist. 6 months later, services updated, APIs changed, internal architectures evolved. Documentation wasn't updated. Now the documented abstraction doesn't match the actual abstraction. New team members learn from outdated documentation. Drift between documentation and reality grows. Organizational drift means nobody understands the abstractions anymore. The architect who chose the abstractions left. The team that implemented them moved to different projects. New engineers inherited systems built on abstractions they don't fully understand. They know how to use the interface, but not why it works that way or what constraints exist. Tribal knowledge drifted away. The abstraction still functions, but institutional understanding of it drifted. Dependency drift introduces hidden brittleness. Your abstraction depends on other services. Those services update, change APIs, modify behavior, or add new dependencies. Your abstraction still works, mostly. But edge cases break. Failure modes change. The abstraction drifted because its dependencies drifted, and you might not know until something breaks. Drift is insidious because it's gradual. No single change breaks the abstraction, but cumulative drift transforms a well-understood, reliable abstraction into a mysterious, fragile system you're increasingly unable to predict or control. Now let's talk about what happens when abstractions face stress, high load, rapid changes, incidents, unusual conditions that exceed design assumptions. Load reveals abstraction breaking points. At 100 requests per second, your API abstraction is flawless, At 10,000 requests per second, rate limits engage, queuing introduces latency, back-end systems struggle. The abstraction worked under normal load. Stress reveals it's not infinitely scalable, it has capacity limits that weren't visible during typical operation. Rapid change exposes abstraction rigidity. Abstractions optimize for common operations, when you need rapid, unusual changes, emergency scaling, emergency migrations, unconventional configurations, the abstraction becomes an obstacle. The simple interface that accelerated normal operations now slows emergency responses because it doesn't support the operations you suddenly need. Incidents reveal hidden dependencies. Under normal operation, abstractions appear independent. Under stress, hidden dependencies emerge. Your compute abstraction depends on the network abstraction, which depends on the DNS abstraction, which depends on the control plane abstraction. When one fails, cascading stress reveals these dependencies the abstractions were hiding. Concurrent operations create abstraction contention. One team uses the abstraction, smooth operation. 10 teams use it simultaneously during an incident, API throttling, resource contention, conflicting operations. The abstraction was designed for isolated use. Stress from concurrent users reveals it doesn't handle contention gracefully. Stress testing assumptions built into abstractions. Abstractions make assumptions, typical data sizes, normal traffic patterns, expected operation frequencies. Stress violates these assumptions. You upload a 10 GB file to object storage, designed for MB-sized files. You trigger 1,000 Lambda functions simultaneously when the design assumed occasional invocations. Stress exposes that abstraction design assumptions were narrower than you realized. Stress doesn't break abstractions suddenly, it degrades them, revealing weaknesses and limits that weren't apparent during calm operations. Finally, let's address what abstractions fundamentally cannot overcome, the hard limits that no amount of engineering can abstract away. Physics cannot be abstracted. Network latency is bounded by the speed of light. Data in New York and data in Tokyo are 11,000 kilometers apart. That's 36 milliseconds minimum at light speed, more in practice with routing. Abstractions can hide network complexity, but they cannot eliminate physical distance. When your application requires global consistency with low latency, the abstraction hits physics. No amount of clever engineering makes photons faster. Complexity cannot be eliminated, only relocated. Abstractions don't remove complexity, they hide it. The complexity still exists, managed by the provider instead of you. When that hidden complexity causes problems, you're dependent on someone else to solve them. And some complexity is irreducible. Distributed systems, consensus, consistency trade-offs. These are inherently complex problems. Abstractions can simplify your interaction with them, but they cannot make the problems themselves simple. Trade-offs cannot be abstracted away. CAP theorem says you can have consistency, availability, or partition tolerance, pick two. Abstractions cannot change fundamental trade-offs. They can make good default choices, but they cannot give you things that are mutually exclusive. When you need strong consistency and high availability during network partitions, the abstraction hits a limit. Reality has constraints. Cost structures reflect real resource consumption. Abstractions can simplify pricing models, but they cannot abstract away that compute, storage, and network transfer consume real resources with real costs. When abstractions hide cost structures, you might build architectures that are economically unsustainable. The abstraction cannot make expensive operations cheap. It can only hide the expense until the bill arrives. Customization beyond abstraction boundaries is impossible. Abstractions provide what they provide. If you need functionality outside the abstraction's design, you can't have it without dropping to lower abstraction levels or building it yourself. The abstraction cannot be infinitely flexible while remaining simple. There's a ceiling to what abstracted services can do. Beyond that ceiling, you need different abstractions or no abstraction. Trust cannot be abstracted. You must trust that hidden implementations work as promised. Abstractions require faith in provider competence, security, and reliability. You cannot independently verify what you cannot see. This trust requirement is a fundamental limit. The more the abstraction hides, the more trust it demands. Failure domains cannot be completely isolated through abstraction. Abstractions promise to isolate you from infrastructure failures, but providers have cascading failures, regional outages, global incidents. The abstraction cannot make you immune to failures in the systems implementing the abstraction. Your abstraction depends on layers below it, and failures propagate upward. These aren't temporary limits that future engineering will solve. They're fundamental constraints inherent to distributed systems, physics, economics, and the nature of abstraction itself. To wrap up, abstraction is the foundation of cloud computing. It's what makes cloud accessible, scalable, and manageable. But abstractions are leaky, limited, and fragile under stress. They drift from ideal states. They hit walls that no engineering can overcome. The best cloud architects understand abstractions deeply enough to know when to trust them, when to work around them, and when to abandon them for different approaches. And remember, abstractions are tools. Use them wisely, understand their limits, and never forget that complexity hidden is not complexity eliminated. Thanks for watching. See you in next one.